So the first one, we're going to convert that to DMS, so 49.732. So we've got the 49 degrees. 0.732 times 60 gives us 43 minutes. And now from that, we're going to subtract the 43 and multiply by 60 again to get 55.2 seconds. How many of you had that? A few of you? Now converting back to decimal degrees here for this one. We're going to start with the 54, and what are we going to do with it? Divide by 60, good. And then add 14, and then divide by 60 again, and add 63. So 63.2483 degrees. How many of you had that? Good deal. So now down here, we're adding, let's see here, 27 and 42 is 69, so that's going to be 9 minutes. Carry the 1, 68, 69, so 9 seconds, 9 minutes. 56 degrees, 9 minutes, 9 seconds, did you get? Does that look right? How many of you had that? 2, 3? I'm going to go down to this one, subtracting. Let's see, 78, so that's going to be 25 seconds. 96, so that's going to be 57 minutes. 20 degrees, 57 minutes, 25 seconds. Okay. Next. Times 4 here. 39 times 4 is 156. So that's going to be 36 seconds. Carry the 2. 72 plus 2 is 74. So that'll be 14 minutes. Carry the 1. 164, 165 degrees. So 165 degrees, 14 minutes, 36 seconds. Yes, no. Anybody else get that? Now dividing by 6 here. 27 divided by 6 is 4 degrees. That's with 3 degrees left over, so that's going to be 180. So that's 219 minutes. Divided by 6 is 36, right? Minutes. Which is going to leave us with 3 left over again, which is 180 seconds. So 222 divided by 6 is 37, I believe. 4, 36, 37, is that what you got? If you're trying to remember how to do that in the calculator, 27. Of course, mine's going to be different than yours because I've got the graphing calculator. 27, oops, I gotta go back. 39, second angle, minutes, and then 42, alpha, seconds, divided by 6. And then, of course, I got to change it back. The DMS, 436.37 is correct. How many of you had all 6 of those right? Like 2 of you? How many of you think you can do them, even the ones you got wrong? Okay, how many just want to go home and cry? So find the complement of 67 degrees, 18 minutes, 39 seconds. Find that for me quick in your notes. You gotta do alpha, and then it's down on the bottom of the key, bottom right of the keyboard.
How do you change something from decimal to minutes?
DMS on your calculator. So what'd you get? I would guess you got 22 degrees, 41 minutes, and 21 seconds. Yes? Complement adds up to 90. So find the supplement of 81 degrees, 53 minutes, 19 seconds. Find that supplement quick.
No, supplement's 180. Did you get my test time?
I think so. I don't have it graded yet, but it's sitting in the file.
Okay, now I'm not doing it.
So did you get 108 degrees, 6 minutes, 41 seconds? No? Oh, so it'd be 98 degrees, not 108. Does that look better? 98 degrees, 6 minutes, 41 seconds. Does that look better? Okay, there's still a few of you working on the quiz, and that's fine. Take as much time as you need. We are going to go ahead and talk about some new material here quick. So we've been talking about triangles, and we're going to, well, triangles and angles in particular. We're going to focus in on triangles today for a little while. So we're going to look at triangles that have special qualities like this one. What type of a triangle is that? Not everybody at once. What special name does that have? Isosceles. Very good. An isosceles triangle has two sides that are equal. In this case, those two sides, because they each have one slash in them. And a third side that is different. Now, in triangles, there's one very, very useful rule. And that is the largest side is opposite the largest angle. So now in this case, in this triangle, one side is obviously smaller than the other. So I'm going to label these angles A, B, and C. Which angle would be the smallest? C has to be the smallest because opposite it is the smallest side. And for that to be the smallest side, it has to be opposite the smallest angle. What can I say about angles A and B? Why are they the same? Yeah, because their opposite sides are equal. For one to be bigger than the other, its opposite side would have to be bigger than the other. So they can't. Neither one can be bigger or smaller because they have the same opposite side. In an isosceles triangle, there are some interesting things that can happen. We can go like this from the angle between the two equal sides to that opposite side. Now there are some things we can do. An angle bisector cuts an angle in half. So if that brown line is an angle bisector, what that's telling us is this angle up here is cut in half. Well, what does that tell us now? Let's draw that out bigger. Let's draw my isosceles triangle a little bigger. So I'm going to cut this down through here, and that's going to be an angle bisector, making this angle into two equal angles. Well, I already know that this angle here and this angle have to be the same. In a triangle, what do the three angles have to add up to? 180. So because the three angles always have to add up to 180, if I have two angles are equal, you know, this one's equal to this one, and this one's equal to this one. What do I know about the third angle here? They have to be equal. So this angle has to equal that angle. But what do those two angles have to add up to? Well, it makes a straight line, right? So they have to add up to 180. If they're equal and they add up to 180, they have to be right angles, 90-degree angles. So that angle bisector ends up being also an altitude. An altitude goes from a vertex to the opposite side and forms a right angle with that opposite side. It can be used for finding the area. If I multiplied the length of this base times that altitude and divided by 2, I would find the area of that triangle. Well, now obviously this side is equal to itself, right? That blue line I drew, that angle bisector. These two sides are equal. If all three angles are equal and two of the sides are equal, then the third side must be equal. In other words, this piece and this piece are equal to each other. That's what we call a median. We draw it from a vertex to the opposite side, and it cuts the opposite side in half. So in an isosceles triangle, if I draw an angle bisector in the angle that's between the two equal sides, it is also an altitude and a median. And I'm not going to go through proving it to you, but if I draw in an altitude, guess what? It'll also be an angle bisector and a median. If I draw in a median, guess what? It'll also be an altitude and an angle bisector. In an isosceles triangle, those three things from the vertex that's between the two equal sides will always be the same structure. Now, if I drew it from here, it would be different, wouldn't it? So let's draw in the angle bisector from here. That's going to cut that angle in half like that, right? If I draw in the altitude, however, it's got to come in at a right angle. And if I draw in the median, it's got to cut that opposite side in half, cutting this in half. So because this vertex is not between two equal sides, those three are all different. You see what I'm saying? That only applies because these two sides are equal. So what if it were an equilateral triangle? If I draw in an altitude, what can I say about these two pieces? They're going to be the same. What can I say about this angle and this angle? They're going to be the same. By the way, in an equilateral triangle, what are all the angles going to equal? 60. Because all the sides are the same, all the angles must be the same, and if they add up to 180, they must each be 60. Guys, put the phones away. Screw that. Let's try that again. There. What type of a triangle is that? It's isosceles, but it's also... We classify triangles by their sides. This is isosceles because it has two sides that are the same. But we also then classify it by its largest angle. The largest angle in this triangle is obtuse. So this would be called an isosceles obtuse triangle. So we saw an isosceles acute triangle, which is that first example we had, like that. Right? That's isosceles acute. Why is it acute? Because its largest angle is acute. It doesn't have any angles in it bigger than 90. What's that one going to be? Isosceles right triangle. That, of course, is equilateral. Would I call it equilateral acute? It is acute. Okay, is it possible to have an equilateral obtuse? Or equilateral right? No. All equilateral triangles are going to be acute, so we don't bother saying that because it's just implied. Equilateral triangles are always acute. What do we call it then when a triangle has three sides that are all different? Does anybody know? Scalene. Now this one would be scalene acute because there's no obtuse angles. But just like isosceles, we're going to have scalene acute, we're going to have scalene obtuse, scalene right. We're not going to get into all those because you guys can figure that out. Not necessarily, no. It could be anything. Find that angle for me. I will warn you, this is not drawn to scale. What'd you come up with? 38 degrees. Good. What does that tell me about this triangle? Yeah, those two sides are equal. If these two angles are equal, their opposite sides have to be equal. It is an isosceles triangle, even though it doesn't look like it. It must be an isosceles triangle. So those two lines are parallel, at least pretend they are. And let's say that this angle here is 34 degrees. This angle here is 41 degrees. Nope, that's not what I was shooting for. That can't be. How about this angle here is 71 degrees? I want you to find this angle right here for me. Give it a shot. Not as tough as it looks. What's this angle here? 34. What's this angle here? 71. So what's this angle here? 75. How'd I get that? (180 minus 34 minus 71). Yep. So 75 degrees. So then this angle has to be 105 degrees. 180 minus the 75. Because they add up to a straight line, right? Feeling pretty confident about these? Good. So, in your big books, page 49, exercise 22-1, just 1 through 4, those go pretty quickly. Page 491 through 493, exercise 22-2, 1 through 11, the odds, just finding the missing angles, and page 495, exercise 22-5, 1 through 6, do all those. So that should go fairly quickly. You should be able to have those all done before we take our break.